Welcome to our YouTube channel, guys. So this is the first video that we are probably going to do and put out on our YouTube channel. We've always done our Instagram videos, the time lapses and bits and pieces, and we will probably continue to do those videos going forward. We asked a few people on Instagram that they want a few videos on YouTube, so here we go. This is our first one, so be kind in the comments, and if there's anything you want to do different, you want us to touch on more, then let us know. This job we're currently doing here today is there's 3 A-frames going to a local house. So we're just going to work through the process of us making up the first A-frame. Annoyingly for us, we haven't got the new bandsaw set up at the moment, so we're currently having to cut these ones with the grinder because we can't achieve the 62-degree miter cut that we require for this roof in our bandsaw. So we're going to start by just scribing out, laying out the cut lines in the top of these steels. We're going to cut them out, then we're going to move them over to the table. We've already got one set laid up on the table, and we'll go through the process of us making up the first A-frame that we've got. That's going to have the connection plates for a glulam ridge beam that's going in between them. So just follow on. I'll do a little bit of talking and describing as we go. So this roof has got a 28-degree pitch on it, so we're mitering the tops of these at 62 degrees. That's going to be our plumb cuts for the end and for the miter cut for the ridge joint. So follow on as we go. So the job we got is this. So we are currently doing this A-frame, this A-frame, this A-frame up here, and these, the 2 different types. We've got an end A-frame, which is picking up with a fin plate, picking up the glulam ridge beam that's going across. We've got one with an angle bracket on the end just here. That there is picking up one of the rafters with a technical connection like this for the ridge. This is the engineer's drawings for this job. This is what we'll be working through. I've just printed off the pages that are relevant to the section that we've got to do here. This end down here, we've just got a stub cut off with a base plate, and that's welded on the underside of there. That will be going on to this end down here. And this is, we've been lucky with the builder we got on the job. They've given us a full timber template of it. This is our end down here. This has got the same timber end on it, so it is an exact replica of this. This will have a stub on the end, same layout as this. So we're looking at this one here. At the moment we've got a roof pitch of 28 degrees. We're currently cutting in this cut down through here and the end cut down there over there. At the moment we've got one set already laid out on the table over here at the moment. And we'll prep up the other one. So that's the top end cut, mitered and ready to go. We now know the outside edge length of this is 2514 mil. So I can mark that down, 2514. And our cut is exactly the same cut as we did on the other end. So we can scribe that cut up in the same way. So this is what I use this for all of our measurements that we take. This is the Stabila Tech 700DA. It's got digital readout on it, gives us our angles. It's been really reliable. We've tried numerous different ones in the past from cheaper companies and bits and pieces, and they just don't work. The Stabila is brilliant. We're not affiliated with Stabila at all, yet, if you're listening to Stabila. But we run their levels. They've never let us down. The digital levels are really good, and all of the long levels are good, and I really wouldn't want to be without this one at all. That's that miter marked across there. Flip that back over, square off from that mark there, back across to this side. This section here we've marked out. So this corner down here, this is going to be sitting on a timber stud down here. This is a top line of our steel at this point, and we know we need an end plate on there of 10mm, and we've got a 10mm basing plate on there. So these lines have been marked up onto the table now. I can transfer them back. We can double check and we can check everything in real terms, and then we can overlay it onto the top of the timber template, and we know we've got exactly what our builder is after to go back to them with. So that's this section laid out now, so we know that's our top mark there, so we put a set square on there, scribed up until we've got to, and if you guys can see it in there, that mark in there. Over on this side then, there's our line, we've set squared, straight way up through, that's taken a mark, we transfer that over the top. We can now cut that bottom section off, that will sit perfectly plumb with the horizontal, which is going to sit on top of the timber frame. We can get rid of that and get ready to place it up, and we can use those same measurements now to transfer back to the other 3 sections. So we can easily reference off the one we've already done now. This one's previously been cut. This is replicated. This is that underside edge. If we take the measurement for that across there, we're 2360. If we then spin you around until we can see that one, I've scribed the upstand mark at this point on here, which is the same off the line on the floor. We can double check that we're running the same. Pull to there till our line 2360. We know if we cut this one to those lines, that's an exact replication of the one we got over there. So the next bit we've got to make up on these now is the section that's going on here. So these ones have got a stub leg that's coming down with a 10mm base plate on the bottom of it down here. It's not a mitered joint like a standard roof truss would be. These ones have been designed to replicate the timber ones that are going to be. This is what the engineer came up with. So this is coming down, then we have got a stub coming in here, 10mm plate. That's going to have, I can't remember if it's 2 or 4 fixings into the concrete that this is sitting on, so we'll have to reference back and check that again later on before we make the base plates. So we want the stub that fits down here minus the 10mm for the thickness of the base plate. This is, the bottom of our table here is datum 0 for us. All measurements have been taken back off of that again then. So luckily, because of the way everything's been cut, the other end of this beam, the remainder of this that we've already cut off, is exactly the same angle that we need to go on here. So now we can take one of the stub sections, take it to the bandsaw. That's from the point there, 175 back there. Square that off. These are our stubs. If I move you around a bit, you can see the lines. Right, so this is to be staggered back 10mm. That's sitting there nicely on the line. It's given us a 10mm clearance down there. That's also given us our 10mm for our base plate to sit on the bottom. So now we're going to start making up the plate work for the bits and pieces. So that's the technical drawings we had. So we need to make that fin plate. Sorry about the horse. My wife's stable is the next door, so you are going to hear a horse neighing in there at the moment, and probably the rain on the workshop roof. So try and just forget about that while we're going on. So right, back to what we're doing. Fin plates. We've got a big fin plate getting in there. You can see it's just marked in with blue in there. So we have got a plate. We've got 155mm of steel. We want to have a 15mm gap between the end of the A-frame and the glulam. Edge from the glulam into the first hole, we've got 90mm, and then we've got 50 again after that. So we're looking at the first plate's going to need to be 310 on that. So we've got one A-frame that requires a 310 mil plate, because that's the one that's going to have the angle on the end of it. We've then got 2 A-frames that don't have the angle on the back, so their fin plates go right the way through the apex, and they're picked up the glulam on both sides. So then we need 2 of them. We need the same setup again, but we need the extra to run through to pick up on the other side over there. So those ones there are going to be 465mm. So We'll get the 300 by 10 flat plate then off, we'll bring it over to the table now, start to mark that up and cut that out with the plasma cutter. Right, so next to lay these out, so we know we want one plate of 310 long. So for me, first thing I'll always do is just check that the previous cut, or in this case the end of the plate, is running square, so that's running square. Now, I use my own cutting guide, which I've got here, which we run the plasma cutter down the side of when we're cutting everything. Now I know that this plasma cutter runs 14mm offset to the line. So wherever I put my line, if I start cutting in a minute or two, I'm going to need to be 14mm off the actual line. So that means on this, if we want 310, I'm allowing myself an extra 14mm. We want to be 324mm. Let me find a tape in a minute. So we want 310mm, which is there, and then we need to allow 14mm extra, which we'll take for our guide. So we want to be 324mm across there. So if we square that across now, so that's our cut line. That's the one we actually want to be checking that we're cutting on. That's our 324, sorry, which will be our guide line for setting up on. Exactly on the edge of the line that we set up a minute ago. Right, so there you go, that's that first plate cut off. We wanted 310, we've got 310. We took the camera in. There we go. You see, 310. It's like science and math all coming together in one video. As you can see, the edge is pretty clean once that's been cut off. We do have this nice tool from Fireball Tool. Perfect for taking off dross from plasma cutting, oxyacetylene cutting, and it's a good chipping hammer as well for when you're welding. So go have a look at them. Fireball Tool, really good. They also do the fabrication squares, which we'll use probably in another video soon. Right, so that's the 310mm plate done, and then we've got two of them to do at 465. So you don't need to watch me do that again. So I'll stick it in time lapse so you can see that sped through quickly. Right, so next thing for us to do now is to set in the holes. So we have got our measurements. These are our holes going through here. M16 bolts, so we will go 2mm oversized, M18s for us on that. So that's fine, so we know. Right, it's not very easy to see with this light. That is our 50mm mark down there. Then going back off our drawings, we have got 90mm in from the edge on that one. And we've got another 90 to the second one, so that's 180. Right, they're scribed. Let's Right, so there are reference points. You can centre punch that one. Same with that one. And I know for me, the way this one's orientated now, that's the top. But I always personally like to give myself a centre point punch on the top, so I know it always stays the top. Right, so that's that one done, which is for the single end. That's a single fin plate glulam connection. And we've got our wider plates here now, which are going in. So they're going to have the same setup on them in the fact that we're going to be 50mm in from the end on both plates. There's 50 there, 50mm on this end. Same procedure again. Let's scribe that line. Same on this one. 90 and another 90, that's 180. So one of the companies that we are brand ambassadors for and have worked with for a while now is Rotabroach UK. We've been working with these guys for probably 12 months or more now. They sort of partnered up with us and provided us with our mag drills and bits and pieces through all of the videos and stuff we've done on Instagram. So we've been working with them for a while. So as well as a drill, so we're currently, this one here is their big one. This is the Element 100 mag drill. This will drill up to 100mm. It's an absolute monster. Break your back for trying to carry the damn thing around, but it's a fantastic piece of kit. We're using these as well. These are the Rotabroach mag cutters. They're really nice size box, good range, nice and sharp. We've been using these ones for quite a while now in conjunction with some other brands, but these are predominantly what we tend to run now in the workshop if we're using them in the mag drill. Right, that's that in there. Well, that's the wrong speed setting. We had that last time using this for some countersinking, so let's flip that a minute. The nice thing about this is it has got four different gearbox settings on this drill, so you pretty much can find a setting for anything. Let me just find the bucket a minute. Right, let's try again. Right, so I know that the plate that's underneath there is going to be exactly the same as this plate, so I'm with the same hole configuration. So we've just clamped the top plate that's already been drilled onto the bottom one. I know you don't need to bother centre punching this one or lining it at all. I can literally just use this first one as a template to drill the second one with now. That's the 3 fin plates done, as you can see, because that was the top template. They're exactly the same underneath. So So I've just cut the base plates out now, which are going to go on the short stubby legs. These have got to have 4 M12 resin studs in these. So let's just scribe these out and I'll get these ones drilled and ready to go. Next thing up is those plates in there. We need the 10mm plate for the underside and the 10mm plate for the upstand. So we get them cut out and then that's pretty much that. Once those 2 plates there are done, I think that's the last of all of the prep work to be done before we can start putting all of this together then. Right, so let's get these tacked up now. These ones here, they're all set up. We know they're square. Got everything worked out on that for the plates. Let's get them tacked up and get these ones welded up. Right, so this is our new welder. This is what we're currently using at the moment for most of our jobs. This is an EWM Phoenix 355 Pulse. Currently at the moment, this one we're probably going to be running around 226 amps, 26.4 volts for putting these base plates on here at the moment. They're only 10mm thick going on their 8mm thick wall on this steel. You can set this one in a lot of different ways through, this is pulse, non-pulsed, super pulse. I quite like it running it in the pulse setting. Super pulse has its place if you don't want too much heat input in certain situations. It works really well. There's some rough settings. If you're doing a horizontal fillet weld, you can pretty much just select the plate thickness that you're working with and it will give you some pretty close sort of figures that you want to be using for that thickness and material. You can then trim it up and down accordingly on the volts. You can trim the amps on it. You can go by wire feed speed and setting it straight off your straight amperage. So I'm gonna run these out now, 226 amps, 26.4 volts, and see what it runs like. And then we'll have a look at the welds. And then because everyone's an internet weld warrior these days, everyone can say how shit they look and give me a load of abuse about it. But hey, let's have a look. Now that end over there is done, next thing now is to get these stub sections put on. We've already got our lines marked here on the table from earlier on. We can set that up nicely there. Right, so now this one is set up on the top up here now. Now I want to lay this section down, ready for, hold on a minute, ready for us to weld on the top plate on it now. So that's this section now is ready to go. We've got the stub leg on that one. That one up there, it's got its end plates on. So I'm gonna line these up on the table now, get them back on their marks, get them pinned down tight to the table now, and then we will clamp them down and put the fin plates in, get the fin plates in, marked up, squared up, tack them in, then we can weld the whole frame up, and that'll be this one moved out the way when we start on the next ones. Right, we know that we need, don't know if you can read down there, 124 degrees. 124 degrees. Absolutely spot on. That's exactly what we're looking for. So we can go on now and clamp these down into place, slide our plates in between, tack them up, and we're good to go. So what I've done here is we've got, I've put the plate in there now, we've just got it into position. I'm using one of these pier small props with a tripod on the bottom, so we can just get that at the right height to sit the plate on. We've got the plate in there, and on, if we look on this side, I've put scribe marks in here. That's the center point, and then scribed it to know the point which is this height within our web. And then we then got the spirit level on the top up there. That's given us our plumb on that. And then if we go around to the other side of the table, to be able to check to see that we've got, you can't very well see it in the video probably, but to see that our plate is not like this or like that, we've put a set square down the table, put a spirit level down the middle. You can stand back from down here now and visually be able to see whether or not the vertical on that top plate is exactly where it needs to be. And so this one's in really good now and ready for us to final tack this one up and get it going in. Because we've got repeat ones to do, we've also just put some angle iron brackets down here, one there, and one over there. We know now that this frame is going to stay tight to that. We'll clamp that down, and then when we bring the other frame up in a minute, we'll be able to stick the steels on top of the table, push them up tight to these angle brackets, and we know we're going to be able to replicate what we've got there now. We're keeping the outside edge of this frame flush with the edge of the table on the angle bracket. It's marked up on the other side over there as well for it. So it should allow us to easily replicate all three of these. So this will be the first one. This has got the fin plate running right the way through the middle of it. You see it above and below. We've got one more like this, and then we've got the other one which will have a fin plate on this side, but it will come flush with this point here, and then we'll have an angle bracket coming off that side. This is the sort of weld that we're getting from the Phoenix 355. So this is just running pulse setting, running through. But I mean, as you can see, it's I don't know if it's focusing well, but it's a very nice smooth weld profile that it gives. Just runs in really, really nice. Been really, really pleased with this machine so far. So there we go, that's this A-frame all done now. That's the fabrication work done on this, and this will head straight through to paint later on. before heading off the site. We've got 2 more left to go here in the workshop, so we'll get those made up. These will go off to be fitted. So just a massive thank you to everybody who's taken the time to watch the videos. If you could like and subscribe, I'd really appreciate that, and we'll know whether or not there's enough interest to carry on doing these videos. And I just wanted to say a big thank you also to Robin Clevitt and Ed. Robin we met on the Metabo trip to Berlin recently, and it was only because of Robin and Ed and their push to say, go and do the YouTube videos and put some long videos out of the work that we do, that we're actually here doing this now. So go and check out Robin Clevitt's YouTube page and see how the real master of the carpentry world goes. But so yeah, thanks to Robin, thanks everybody for watching, like and subscribe, and we'll see you on the next video. Cheers now, bye. And just as a little bit of bonus footage in case anybody's still hanging in here, that is all 3 of them put together. So we can see they make a pretty good pair, or a trio should I say. That's using the template that was given to us. So I mean they line up pretty bloody well. Same with the ridge line there. And then the ends. All in all, couldn't be happier with the way that these 3 all went together. They've worked out perfect.